Hi guys, Levi here from Bright Young Brains. So in this video, we are going through grade 12, 11, 10, 9, 8. So it is basically unknown what grade this paper is. However, the idea is for you to try it out. The link is in the description so that you get an idea of how well you can answer these questions based on the level of knowledge that you have. But anyways, it says here 50 shoppers were asked what percentage of their income they spent on groceries. The full set of responses is given in the table below. So they said here, percentage between 10% to 20%, going on and on and on, 20% to 30, 30 to 40, going on and on and on until 50 to 60. So we can see that these are the frequencies, right? And then, since they said the total is 50, we can put 50 over here. Then they say they determine the following. The estimated mean percentage of family income allocated to groceries. The space on the table can be used for workings if necessary. So if you're going to work out the estimated mean, right, let's see the other sets of questions. The model class, okay. So we're going to work out the mean. What you have to do is you have to get the midpoints of each of these, right? So let's maybe put here midpoint, because you want to get the midpoints of each of these. 10 to 20, that's 15, and then 25, 35, 45, and then what you call 55. Now what you do is you want to now what you may call, you want to get your midpoints, and then you want to multiply each frequency with the midpoint. So here you want to say the frequency times the midpoint. Let's just get those values, and then we want to add them up. You see, 15 times the 6. Let me just grab a calculator here so that we can just get all those totals that we need, because yeah, we do need those totals one after the other. So calculator says here 15 times 6 is going to give us 90. 25 times 14. Woo! Big number, bro. And about to work that out without the calculator. So 25 times 14, sorry, 350. 35 times 16 is giving us 560. 11 times 45 is giving us 495. 3 times 55 is giving us 165. So you want to add up all these numbers, right? 90 plus the 350 plus the 560 plus the 495 plus the 165. You see, that's going to give you 1660. So this total, you want to take that total, right? And then you want to divide it by 50. So let's see what this gives us, right? This is giving us an average of 33.2%. This paper wants us to round off to 2 decimal places. So let's keep things moving. They said, what is the model interval? The model percentage interval. So the model percentage interval is the class where you have the highest frequency. So that's from 30 to 40. So you're gonna say here your x value is gonna be bigger than 30, smaller or equal to 40, as we have here. So that's 16. Let's keep things moving, you know. Let's see. In a school, they said here, boys and girls were asked about the time they usually spend on the internet over a weekend. These results were displayed in box and whisker plots as shown below. So you have the box and whisker plot for the boys and the one for the girls. Question number 1. So use the plots to answer the questions that follow. Determine the interquartile range for the boys. So the interquartile range is always Q3 minus Q1. So the idea is if they said semi-interquartile range, then you would divide the interquartile range by 2. But then here they just say interquartile range. So you have to remember that your data for the boys, this is the minimum, this is the max. You have Q1 here, Q2 here, Q3 here. So here you have 6 minus 2, you see, 6 minus 2. The interquartile range is just a simple 4, nothing crazy. Then they said, what percentage of girls usually spend 5 or less hours on the internet over the weekend? 5 or less, it's like 5 or less. So the idea is, remember box and whisker diagram. Q1 represents 25% of the data, Q2, 50% of the data. This here seems to be at Q3, which is 75% of the data. Now, what that means is, from this point here going to the left, it's telling us that that's where 75% of the data lies. 75% of all the girls spend 5 hours or less, you see. So it's here 75%. And then here it says, Jenny said that the graphs shows that the same number of boys as girls usually spend between 5 and 6 hours on the internet over the weekend. Under what circumstances would this be true? So what we're seeing is between 5 hours and 6 hours, right? From 5 hours to 6 hours, it's 25% of the data for the girls because it's from Q3 to the maximum. That's 25% of the data. For the boys, it's from Q2 to Q3. That's also 25% of the data. But then here they're talking about the actual number of boys and girls. So the answer here is the only way that you will have the same number of boys here and the same number of girls is if you have the exact same total for the boys and the exact same total for the girls. Because remember, 25% of a certain number is not 25% of another number if those numbers are different. So the only way that you can have the same boys as girls between 5 and 6 hours is if the total number of boys and the total number of girls is the same. Because that would mean that 25% for the one set of data is equal to 25% of the other set of data. So the only circumstance where this is true is if the total boys is the same as the total girls. There we go. Then it says here, which plot is skewed to the left, boys or girls? So in terms of being skewed to the left or being skewed to the right, you have to look for the distance between Q1, Q2, and Q3. If Q2 and 3 are close to each other, you have to look at where the larger space is. If the larger space is to the left, it's skewed to the left. If the larger space is to the right, it's skewed to the right. So here you see between this space and between this space, this is larger, so it's skewed to the left. Between this space and this space, this is larger, so this girl's one is skewed to the right. So the ones that's skewed to the left is the boys. You see. Here it says choose the correct option. The average, this is the mean average of time boys spent on the internet over the weekend is more than 5, less than 5, or equal to 5. So if you're going to get the average using a box and whisker diagram, you want to keep in mind that your average is usually at the space that's more open. Like for example, your average, you see here they're comparing it to 5 hours. 5 hours for the boys, right, is Q2. So when you want to get an idea of where your mean is usually at the side where the space is a bit larger. So you see here, this portion here is larger than this part. So your mean is to the left of Q2. If this part was larger, your mean would be to the right of Q2. For example, for the girls, the mean is to the right of 3 hours because it's this part that's larger. So for the boys, your mean is below 5 hours, you see, because it's the part that is larger. So here we're gonna choose B. There we go. Moving on, question number C. It says the ages of 20 people are shown below. Fortunately, this is already from minimum to maximum. Nice. And then we have to put the 5 number summary. Not so bad. Maximum is 30, minimum is 15. So this is 20 people, right? So already what we do know is the middle, which is Q2. We can say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the middle. So the idea is normally what you can do is, remember, these are the positions of your quartiles, positions of Q1, Q2, and Q3. So for Q1, the position is going to be a quarter n plus 1. For Q2 is going to be 2 quarters n plus 1. That's how you get the position. For Q3, it's going to be 3 quarters n plus 1. But then anyways, fortunately for this set of data, the middle, which is Q2, you can just add these two numbers and divide by 2. 15 plus 19 over 2. What does that give us? That's going to give you a 17. For Q1, you have to say 1, 2, 3, 4, 5 numbers, and then 1, 2, 3, 4, 5 numbers. So it's these two together. 7 plus 9 divided by 2, that's 8. And then here also 1, 2, 3, 4, 5, right? And then 1, 2, 3, 4, 5. So you have to put these together. That's like 23 and a half. Let's keep moving forward to question number 2. Question number 2 says the following. So for theta, right, between 0 and 90 degrees. So a cos graph with 2 here. Let's say so for theta. We're solving for theta here. You have to say shift cos. This is like shift cos and then 0.947. In the calculator, what's what we're gonna get here? I think let's not round off yet. And then here, let's divide by 2. Divide by 2. We're gonna get a value of theta here. Let's see. Our value of theta is just going to be, if you're gonna round it off to 1 decimal place, it's giving you 9.4 degrees. Perfect. Next says we need to solve this. So solving for this, remember you can divide both sides by a third. You see sine, you have theta minus 20. And then this divided by a third, you can literally just put it like that in your calculator. This here divided by a third. And then what is that gonna be now? This is gonna give you 0.876. And then let's see here. But obviously, yeah. The thing is, if you've not gotten to your final answer, right, you normally want to make sure that your answer is rounded off to quite a few digits. You can even say 3 digits, 4 digits, if it's not like your final answer, because if it's not your final answer, the more values you have in terms of decimals, the more accurate your final answer is likely going to be. So anyways, from here, obviously, your initial answer, the whole thing was what you may call, the whole thing was, this is not even rounded off, so it is all good. So from here you can see that the 20 has to go to the other side. No, what am I saying, bro? There we go. Now you have to say shift sign. Say shift sign with a 0.876, and then you have a theta here minus 20. And then this in your calculator, let's see, it's going to give you 61.2. And then here you're going to take the 20 to the other side. It's going to give you 81.2. There we go. That's the way we like it. B says the following. Use the trigonometric ratios to find to 1 decimal place the values of x and y. So it's a 5-mark question, and it doesn't seem like it's a difficult question, fortunately. But so looking at where x and y is, you want to look at the triangle that has more information for you to get help. You see, the one on the right side here has more information, so I can get x first, because you have an angle here, right? And you have an opposite, which is x, the adjacent, which is 7. So you can use tan. Tan 51 is equal to opposite over adjacent. So to get x, you can just multiply both sides by 7. You have 7, 10, 51 equal to x. And then our value of x in this situation is just 8.6. So this is x. So in this situation, you want to remember that you would probably be thinking to yourself, okay, fine, but then we are going to be using a rounded off value for your other question, for your other workings, which is okay in this situation because it's all one big question. So here you can have 8.6. To get y, it's an angle. So you see you have the opposite and adjacent also. So you can say 10y is equal to opposite over adjacent. And then to get y on its own, you can say shift 10, 8.6 over 5. There we go. And then shift 10, 8.6 over 5. Wow. This is funny enough, giving us 8.6 over 5. Yeah, this, if you round it off to 1 decimal place, it's going to be 59 point. It says to 1 decimal place. So this is going to be 59.8. 59.8. There we go. Then they said here, use the value of the following determine the value of the following without using a calculator. Show all steps. So the one thing to remember is that cot, you have to remember you have sine, cos, and tan, right? However, 1 over sine has a name, 1 over cos has a name, 1 over tan has a name. So the name for 1 over tan is cot, and then the one for sine is cosec, and then one for cos is sec. Yeah. If you see these in your trigonometry papers, you want to keep in mind that these are the what you may call, this is what all these mean, you see. So the big idea is, with all this being said, right, you want to keep in mind that when we are seeing the cot there, when we're seeing cot, when we're seeing cot, we should just remember that it's just 1 over 10. So if it's squared, it means that we have to square this 1 over the 10. But anyways, let's see. This is 2, 10, 45. Let's just write it out first. Cot is, we said it's 1 over 10. So because there's a 30 there, it's okay. We can put 30 there. We square it. Sine squared 60. So before we get on, we have to know our special triangles, you see. There's the 30-60 triangle, 30 degrees, 60 degrees, and 90. So if you have 30 here, sine 30 is 1 over 2, which is a half. And then you can put square root of 3 here. The 45-45 triangle, you have to know it also. It's 1 and 1. No, 45 and 45. 1 and 1. And then square root of 2. And then here you can see tan 45 is opposite over adjacent. So that's like a 1. And then tan 30 is like adjacent over, opposite over adjacent. So it's like 1 divided by 1 square root of 3, 1 over square root of 3. The whole thing is squared. So don't forget to put it like that in your calculator. This whole thing is being multiplied by sine squared 60. So sine 60 is opposite over hypotenuse. So it's like square root of 3 over 2. Now, the fortunate thing is you can just put all this in your calculator the way that it is. So looking at the way it is right now, you may be thinking to yourself, okay, let's just maybe let's put one step in the calculator. So all this in the calculator, let's see what you're gonna have here. You are gonna get a 3 in the calculator here. This in the calculator is gonna give you a 3 over 4. And then this is just going to give you 2 plus 9 over 4. To 1 decimal place, this is going to give you 17 in the calculator over 4. And then obviously to one decimal place, 4.3. Great. It says if sine theta is equal to this between 90 and 270, determine without the use of a calculator and using a stable diagram the value of this expression. So the idea here is your diagram, it has to be almost like a cross. So 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees. And then the big idea here is your diagram has to be between 90 and 270. So it's either going to be over here or over here. And it's a right angle triangle. So if you're going to see sine theta is 5/13, the idea is, remember, this is opposite over hypotenuse. So the idea is, when you say a negative here, the negative, you have to either allocate it to the number at the top or the number at the bottom. Now, the hypotenuse will always be a plus. It'll always be a positive number. So the opposite is the one that has to be negative. So the idea is, remember, your sketch has to be between 90 and 270. So your sketch either looks like this, right? Or your sketch looks like this. So for you to determine which of these triangles your sketch is, you have to look at this. You see, it says sine alpha is equal to opposite over hypotenuse, because we said the hypotenuse is a plus. So this is opposite, has to be a minus, you see. So if this is the opposite, you see it's a plus because this is going upwards. So your sketch cannot be here. Your sketch has to be down here, because that's the only way you can have a -5, you see. So your sketch has to be down here. The hypotenuse, we said it's a 13. Now, obviously here you have to work out the adjacent, which is where Pythagoras comes in before you even worry about doing anything. 13 squared is equal to -5 squared plus, let's just say, x squared. Don't forget to get your answer here as a minus, but let's see. 25, 13 squared is going to give us 169. And then, let's see, 169 minus 25, 169 minus 25, that's like 144. 144, and then there's like x squared. So if you square root it, remember your answer is plus or minus, which is why here you have to choose a -12 because it's on the negative side. And then here you put your alpha. That's how you draw your sketch first. So now all these other questions, they're going to be very easy, because now if they're asking for cos, 4 cos alpha minus sine alpha, you see 4 cos alpha minus sine alpha. You use your sketch, because 4, you have 4. Cos alpha is going to be adjacent over hypotenuse. And then sine alpha is going to be opposite over hypotenuse. There you go. So all this in the calculator, let's see. Your next step here is going to give you -48 over 13. And then like plus here, +5 over 13. And it's going to be -43 over 13. But they did say we should put our answers to 2 decimal places, but I mean, this fraction is good enough as a final answer. So, but obviously you can leave it like this. If you want, you can go one step further and do the 1 decimal place item, which is just going to be -3.3, which is okay. The next question is question number 3. Question number 3, we have more trigonometry. It says here, the sketch shows the graphs of f and g between 0 and 360 degrees. And then it says here, let's see, this looks a bit like I mean, at first glance, we might think we know what kind of graphs these are, but you know how trigonometry can be. So let's not assume. But anyways, let's see. The next one says determine the equations of f and g. So looking at what f and g is. So f looks like a sine graph, g looks like a cos graph. Now the idea is you have to know the theory behind your sine graph and your cos graph. Now a sine graph, the standard version of the sine graph is y is equal to sine x, or rather the standard version is y, or let's put it this way. With your sine or cos graph, the format of your equation is y is equal to a sine dx minus p plus q. The idea is a, b, p, and q mean something. So a standard equation of a sine graph, the numbers that it has is 1 sine 1x minus 0 plus 0. Because a is the amplitude, that's for the standard one, the one that we know we always get from our amplitude, the one that we always get from our study guide, you see. B is the frequency, and then P is the horizontal shift, horizontal shift, and then Q is the vertical shift. So a standard sine graph, you would see it would look something like this. You see, where the amplitude is a 1, the frequency is a 1, meaning between 0 and 360, you see a 1 graph. That's what frequency is. It's a value that goes here. This is the horizontal shift, meaning you would see your graph would not be moved to the left, to the right. This is the vertical shift. Your graph would not be moved up or down. The way f is looking, right? Remember, fortunately, you have to keep in mind that for you to have an equation of our graph, you have to get a value for a, b, and let's say q, because p is a shift from left to right. This graph you can see from 0 to 360. Firstly, you have one graph all the way from 0 to 360. Okay, good. And then amplitude has a formula. The amplitude is always the maximum y value minus the minimum y value divided by 2. So for f, the maximum is a 2, the minimum is 0, divided by 2, your amplitude is a 1. It has not been, so the amplitude we have, there is one graph in a space of 360. It has not been moved to the left or to the right. We can see that. And then it has been moved, a standard graph, right, which starts at 0, has been moved 1 unit upwards. So our q value here is a +1. The equation here is going to be sine x plus 1, because amplitude is a 1, frequency is a 1 shift upwards. Graph of G, just by the way it's looking, you can see it's looking like a cos graph, but it's looking like a negative cos graph, because a standard cos graph would look like this. This would be y is equal to cos x. You see, the amplitude would be a 1, the frequency would be a 1, and it would not be moved up or down. The moment you see a minus cos x, then that graph starts by going downwards, you see. So it starts by going downwards, like this. It starts by going up like that. This is what the graph of what you call negative cos x would look like. It's weird how they're asking for the amplitude for f here when it's something we need to have already gotten up here. But anyways, the graph of G, the amplitude is also going to be the maximum value minus the minimum. You see, so it's going to be maximum minus the minimum over 2. The amplitude for the graph of G is a 1. And then we said this graph has not been moved up or down, because the standard graph, it will go all the way to +1. It will go all the way down to -1, which is what this is doing. You see, it's going all the way to +1, going all the way to -1, and it's flipped over. The equation is going to be negative cos x, and that is that. It's just negative cos x. There is no, it's not been shifted up or down, so there's no plus or minus or anything. Okay. The next one says calculate the amplitude of f. Amplitude of f, we already have it. We said it's just the 2 minus the 0 divided by 2. That's just the 1. Write down the range of f. Range you always have to go the highest value that the graph goes, the lowest value that the graph goes. So the range of your graph of f is between 2 and 0. So the range, you have to say your y values have to be bigger or equal to 2, smaller or equal to. No. Bro, come on. The y values have to be smaller or equal to 2, and they have to be bigger or equal to 0. Because your graph goes all the way to 2, it goes all the way down to 0. And it touches the 2, and it touches the 0. So we have to say it is bigger or equal to the 0 or smaller or equal to the negative, the positive 2. And then they said here, calculate the x values for which f of x is above g of x. So this is saying you have to consider where the y values of f are bigger or equal to the y values of g. So we're comparing y values here. We want a space where the y values of f are above the y values of g. So that's like over here until here where they are equal. And that's like over here. That's the only spots where the graph of f is above the graph of g, you see. So with all that being said, that's going to be from 0 degrees to 180, 270 to 360. So you're going to say x has to be bigger or equal to 0. No. At 0, they don't touch. So x is just bigger than 0, but then x has to be smaller or equal to 180, or between 270 and 360. So you're going to say x has to be bigger or equal to 270. The reason I'm saying bigger or equal to is because specifically at 270, they at least meet, unlike the other portion of our question. X has to be bigger or equal to 270, but then those same x values have to be smaller than 360. You see, because between 270 and 360, that's where the graph of f has y values that are above the graph of g. And then it says here, for which values of x is f increasing? So if they're saying for which values of x is f increasing, they're asking where the y values are increasing. Because remember, f of x represents y, you see. So in this situation, where is this thing now? F of x represents y, right? So the y values of your graph of f, you see here, they're going up until here, then they stop. And then they go down until here, they stop. And they go up again, you see. So they're increasing between 0 and 90 and between 270 and 360, you see. X values have to be bigger than 90. Let me write it this way. X values have to be bigger than 90, but they have to be bigger or equal to 90. No, bro. Bigger or equal to 0 until 90. Come on now. Come on. Smaller than 90. Bigger or equal to 0, but smaller than 90. The reason we're saying bigger or equal to 0 is because specifically where the x values are 0, right? The graph is still, the y values will be increasing. You see, because to the left of this graph, it would just have been looking like that. So it's at 0 here, it's going up until here. Here specifically, it's not increasing at all. So you have to say smaller than 90 instead of saying smaller equal to 90. The other part where it's increasing is between 270 and 360. So you have to say here x values have to be bigger than 270, but they have to be smaller or equal to 360. Smaller or equal to, because specifically 360, it is increasing, because if you carry on, it would look like that, you see. So let's keep moving forward. B, what does B say? B seems like a fairly interesting question, as it should. Because, wait, did it say increasing or decreasing? Oh, decreasing. I read increasing. So what I wrote down here is the one where it's increasing. Let me actually just put it down here as additional information. This is the part where it's what you call increasing. The part where it's decreasing is obviously the part we obviously did not mention. So this part is increasing, this part is increasing. Decreasing is between 90 and 270. So you see here, x values have to be bigger than 90, smaller than 270. Specifically at 90, it's not increasing or decreasing because it's like not doing anything. At 270, it's also not increasing or decreasing, because before that, it would have been decreasing. After that, it's increasing. So in the middle here, none of those things are happening, you see. So let's move on. To B, it says, answer the following. Sketch the graph of this from 0 to 270. So before you sketch, you can easily put your asymptotes first for a standard 10 graph. Your first asymptote is at 90. The other one is at 270. Now, what we do know is the fact that between 0 and 90, right, a standard 10 graph, the idea is this is telling you that this is a standard 10 graph that has been shifted 1 unit down, you see, shifted 1 unit down. So a standard 10 graph would have looked something like this. You see, there would have been 90 here, 270 here, and then there would have been a line here. And then this would have like gone up in the middle here, this would have gone up, this would have gone down, here this would have gone down. So this is what it would have looked like, right? Between this would have been like 90 degrees to 70 degrees. The only difference now is this is a specific 10x. This is just 10x. Y is equal to 10x, right? But then the moment you say minus 1, it means that this whole picture has to be moved 1 unit downwards, you see. So instead of passing here at 0, it's going to be passing here at -1, right? And you may think to yourself, what you call, where will it pass? So what you know is 10, 45 is a 1. So your shape would look something like this, going up. And then instead of it passing at 180, it would pass a bit. You can actually just plot your graph by putting numbers in your calculator, you see, like 10, 45, 10, 180, 10, 135, 10, 200 and something, and all that, so that you can just have an accurate sketch, you see. So for example, let's put 10, 180 minus 1 in the calculator. It's giving us -1. So you have something like this here, of which that shape would then just look like this, going down, meaning the one here, let's see, between 180 and 270, it's like 225, right? So it's like somewhere there. It's like goes up here. Let's see, up there like that. This is what your graph would look like. So just be careful of these things. And then they say, write the equation that would result from shifting this graph 4 units downwards. So moving the whole graph 4 units downwards, you would have to say -4 here. So this would be like 10x minus 5. That would be the result. And then let's move on to question number 4, analytical geometry as it seems. Okay, question number 4, right, says the following. In the diagram below, you have M, you have N, you have L. Then it says these are the vertices of a triangle with these lines perpendicular to each other. If they're perpendicular, already we know something about the gradient of the one line and the gradient of the other line. Then it says here, points S and R and the x-intercepts of lines ln, mn respectively. Oh, they are the x-intercepts of these two lines. Yes, we can see that here and here. And then it says you calculate the length of the line segment ln. Ln, the length. You can just use the distance formula, you see. So ln is equal to distance formula, right? We can say 2 minus negative 2 neo plus, and then negative 1 minus 2. So all this, you can see 4 squared is like 16, negative 3 squared is like 9, this is 25, this is 5. You see, that's the length of ln. Nothing crazy there. Let's keep things moving. It says show that the gradient, this is asking for the gradient, you see, because gradient is the m. Gradient of lm is 3 over 4. Wait, if they've given you the gradient, then they're asking to get the coordinate of k. So lm, you have L here, m there. So you can use it, you can use the gradient formula. You can make this x1, y1, x2, y2. Your gradient formula is going to be y2 minus y1, x2 minus x1, right? So you have, like you can say here, 5 minus 2. And then here you can say k minus negative 1. So it's going to be k plus 1. The gradient you have here, it's like 3 over 4, you see. So here you can just cross multiply. 4 times the value on top here, it's going to be 4 times 3, which is 12. 3 times the value at the bottom here, it's 3k plus 1, see. It's like 3k plus 3. And then you have like 12 minus 3, which is like 9. Divide both sides by 3. Your k is a 3. Then you have got on your 3 marks. 3 everywhere. Calculate the coordinates of t, which is the midpoint of lm, given that k is a 3. So getting the midpoint of lm, nothing difficult there, because you can just use the midpoint equation, you see. So for your midpoint, you have to say, remember, the midpoint of m is going to be x1 plus x2 over 2. The midpoint of y is going to be y1 plus y2 over 2. Two different equations. Now, we're talking about L and M, right? So we can say negative 1 plus the 3 over 2. And then for this one, 2 plus the 5 over 2. So this is like 7 over 2. This one is like 1. So since they want the full coordinate, you have to write it as a coordinate. You see x value, y value. There you go. Determine the gradient of Ln. So Ln is this gradient here. So you can just use the gradient formula as we already know it, you see. So this is gradient, right? Now, obviously, you can just say 2 minus negative 2, which is going to be a plus. And then here you have negative 1 minus 2. Negative 1 minus 2 is going to give you 4 over negative 3. Of which, since these lines are perpendicular, right, you know that they've given you the gradient of Lm, which is this line. So the gradient of the other one would just be this flipped over with a negative sign, as we're seeing here. And then they said we should write down the coordinates of P if LMPN is a parallelogram. So LMPN. So LM, P would need to be somewhere here, and then N. So if you're going to work out the coordinates of P, right, you have to be careful. Let's check the marker location. The marker location, you can see it's out of 2. So this one is, you want to work it out just by looking at it. what I mean by that is you have to remember that your coordinates, they're always linked in a way, you see. So if this is going to be a parallelogram, it means that this has to be a 90-degree angle also, you see. Because this has to be parallel to that, this has to be parallel to that. Now already, what you know is, you want to compare the distances between these coordinates, right? So you already know that from 2 to -1, you would have moved 3 units to the left. So from k, which is a 3, going to the x value of p, you would also move 3 units. You see, so that's why the x value there has to be a positive 6. You see, it has to be a positive 6. So once we have that, you can now compare the y values between these two also. You see, from positive 2 to -2, that's going to go down 4 units. So from 5 going down 4 units, it's going to give you a 1. You see, so the coordinate there, the coordinate there is just 6 and 1. You see, so that's that for that question. Nothing crazy, nothing major. So let's put your 6 and 1, because they said LMPN. So it's like, where's LM and then PN. Anyways, so you see, we just had to compare these two lines here, this point and that point. You see, you're gonna compare this point and that point. So let's move on. Get the equation of Ln. Ln is a straight line, so, and we have its gradient. Perfect. So we can just say y minus y1 got the gradient x minus x1. You see, so the gradient we already have, it's -4/3. And the coordinate that the graph passes through, we can just use L. What is L? -2 and 2. So it's like -2 and 2. So this can be x1, y1. So here you put all that in your equation, and then you make y the subject of the formula. Y minus y1 gradient, which we have -4/3 x minus x1. So you put a plus. Multiply inside -4/3x. Multiply again, you have like -8/3. Then you have like y minus 2, right? The 2 goes over to the other side. You have like -8/3 plus 2. -8/3 plus 2. That's like -2/3. There you go. So what now? That's the equation, because as you can see, it does, whoa, it doesn't look right. This value has to be a positive value. So I made a mistake somewhere. This plus 2. Dog, what is going on here? Let me just double check what I did here. X is, I think I used the wrong coordinate for L. Oh, -1. Come on, bro. Yeah, so don't just leave your answers, because this has to be a positive number. Because remember, you can see on the image, the y-intercept is a positive number. So let's put here, it's going to be a +1. Multiply inside, this is going to be -4/3. And then when you take the 2 over, this plus the 2 would give you a positive 2/3. There we go. That's the way we like it. Okay, moving on. Question 6 out of 6. They said, given that the gradient of Mn, where's Mn? Yeah, it's quite steep. So the gradient is a 7. Calculate the length of Rs. Rs? Oh, okay. From here to there. Well, fortunately, it looks like we can just get the two equations of the two lines and then just get their x-intercepts, because the equation of ln we already have. It's y is equal to negative 4 over 3x plus 2 over 3. The equation of, let's just say ln here, the equation of mn, it looks like we need it. So we can get the x-intercept, which is r, and then we can compare the distance here. So that's how you want to know, that's how you want to go about these questions, you see. Don't be conservative in terms of what you write down. So we already have the gradient of mn, so we just need the y-intercept since we need the equation of mn first, see. So x1 and y1, it's just, it can be any of the two coordinates. Let's pick 2 and negative 2. Wait, yeah, 2 and negative 2. Just want to double check if yeah, 2 and negative 2. Just close this bracket here. 2 minus 2. And then our gradient is a 7. So x minus 2 there, y negative, and a negative gives a plus. So you have 7x here. 7 times the negative 2 is like negative 14, and then the negative 2 over there. So this is like 7x minus 16. There we go. So this is the equation of the other graph. So we want to get the two x-intercepts of our equations, right? So that we can get the distance of RS. So x-intercept here, you have to make y as 0. Making y as 0 here, positive 16. Divide both sides by the 7, it's like 16 over 7. The x-intercept here, which is for the other line, let's see what it's going to give us. We're going to take our gradient to the other side because it's easier to work with like positive numbers. And then let's see here, 2 over 3, right? So you can divide both sides by 4 over 3. 4 over 3, you see. So it's going to be here, this cancels that. X is equal to this divided by that. What does that give you now? 2 over 3 divided by 4 over 3. That's like a half. There we go, half. So all things considered, you have two x-intercepts, right? This is the x-intercept for ln. This is the x-intercept for mn. So let's see. This is like 16 over 7. This is like a half. So the distance here is going to be 16 over 7 minus a half, you see. 16 over 7 minus a half. See what that gives us in the calculator. It's going to give us 25 over 14. To one decimal place, that's just 1.8. Yep, that is all good, all nice. 6 marks. Let's move on. Question number 5, right, says A, B, C, D is a rhombus. There's AC here that is equal to 26. There's BD that is equal to 34. So it's like 26. So remember, if it's a rhombus, don't forget that everything here is equal. And then don't forget that properties of a rhombus, this is a 90-degree angle. If it's a rhombus, also you have alternating angles here because you have parallel lines here. Furthermore, your lines here, they cut the angles in half. So if this is 48, this is going to be 48. If this is 48, this is going to be 48. All that information is stuff you can fill in even before you start. And then the other thing is your lines get cut in half. So this is equal to this, and then this is equal to this. So if this is 34, it means that this is 17, 17. And then it also means that if this is 26, it means that this is 13 and 13. All this information, we filled it in before we even start because it's knowledge that they'll be giving you. They say it gets C1 with reasons. So you're going to start firstly by stating that C2 is equal to 48 also because of alternating angles. And then the next thing you're going to say, therefore, C1 is also equal to 48. The reason is AC bisects angle C. See, the line AC is cutting C in half. The line DB is cutting B in half. So D is also being cut in half, A is also being cut in half. Properties of a rhombus. They want us to get angle DOE. DOC. DOC is 90 degrees. The reason is diagonals of a rhombus bisect each other at an angle of 90 degrees. Diagonals of a rhombus bisect at an angle of 90 degrees. And then they say they hence determine the perimeter of the rhombus. So getting the perimeter of the rhombus, that's not going to be difficult because you see we have a right angled triangle here already. You see 13 and 17. So you can just work out the distance of AB using Pythagoras, and then we can just multiply it by 4. See, so 13 squared, 17 squared, and then AB. So it's like AB squared is equal to 13 squared plus 17 squared. And then square root both sides. We're going to get here 13 squared, 17 squared, AB. So this is going to give us, what is this? What is this in the calculator? 13 squared plus 17 squared under square root, right? This is giving us 458 square root. There we go. And then to 2 decimal places, this is giving us 21.4. There we go. But then now you have to say, therefore, perimeter. Well, let's just use the unrounded off values. So square root of 458 times 4. Why am I writing it to the corner like this? Let's do this times the 4. Just going to be 4 square root of 458. This multiplied by 4 to 1 decimal place is going to be 85.6, you see. 85.6. There we go. So our question, not too bad, not too shabby. Let's keep it moving. The next thing here says it's a question 6. Question 6, we have some Euclidean geometry. And the one thing with Euclidean, as I always say, is the acronym that you want to keep in mind is DRCPT. If you're not familiar with what DRCPT is, it is basically the acronym that is going to help you to work out Euclidean geometry questions, because this acronym, it allows you to be able to recall certain theorems that are somewhat important in your Euclidean geometry. So if you go on the main channel, Bright Young Brains, and you scroll down to the Euclidean geometry playlist, what you're gonna find there is obviously tutorials on like the basics of the theorems. And then you're gonna find a tutorial that says circle geometry strategy to approach riders. Within this tutorial, as you see, it's short, straight to the point. You are going to get an idea of what the DRCPT stands for: diameter, radius, cyclic paths, parallel lines, and tangents. You see, that's going to help you to remember the different theorems that you have when it comes to your Euclidean geometry. So as you can see here, this is the essence of the RCPT. See, Dr. Cape Town, diameter, cyclic quads, radiuses, parallel lines and tangents, because you basically have theorems for each of those things. In our case here, we have, let's see, the setting the time in the diagram, O is the center. So we have a center, right? Meaning we already have a diameter visually. So the moment we have a diameter, this is 90 degrees. And then the moment you have a diameter, let's see, the other thing they said is YIE. So YIE is 50, and then AB is a tangent. The moment you have a tangent, you have the 10 cot theorem. Meaning you have laws here where the angle here, right, is equal to that one. Because this is the tangent, this is the chord. So a tangent and a chord, the angle in between that will be equal to the one opposite the chord, you see. Now this is 50. And then this here, right, is a 90-degree angle. So you have a radius here and you have a tangent there. So a tangent and the radius, they always meet at an angle of 90 degrees. So tangent perpendicular radius. That's another theorem for tangents, you see. And then we have, well, you can get this angle, interior angles of a triangle, but let's not overanalyze it. We have a cyclic quad. So remember, opposite angles of a cyclic quad are supplementary. All those laws you need to keep in mind to help you. So I want Y1. We say it is just going to be 50. The reason is 10 chord theorem. Straightforward. E1 is a 90-degree angle. The reason is angle in semicircle. Angle in semicircle. And then Y3. Where is Y3? Y3 is a 90-degree angle also. The reason is tangent perpendicular radius. Y2 is the middle part here, you see. There are different ways to get it. You can even just say angles on a straight line. Y2 is going to be 180 minus the 90 degrees there, minus the 50 on the other side over there. You're going to get 40 degrees. The reason is angles on a straight line. R1, as we said, you see, R1 is opposite to Y2. They are supplementary because they are opposite angles of a cyclic quad, you see. So Y1 and 180 minus 40. The reason is opposite angles of a cyclic quad. So you see, if you know your laws, these questions are just easy, free marks, you see. 2, 4, 6, 8, 10. Free 10 marks. So let's move on to the next question. Question number 7 says the following. F and E are the midpoints of AB and AC respectively in the triangle ABC. So automatically, if those are each equal to each other, they said here FE are the midpoints. So F is the midpoint of F. No, F is the midpoint of AB. E is the midpoint of FE. There we go. So automatically, at the moment you see this, right, you want to think of the midpoint theorem, meaning that whatever the length is here, this one is going to be double. You see, you don't know what this is, but this is going to be double because of the midpoint theorem. The midpoint theorem states that if one line cuts two sides of a triangle in half, it means that the line that you're referring to would be double the third side of your triangle. Furthermore, the law also states that the line would then be parallel to the other line, the third side of the triangle. So that's the midpoint theorem. Then they said here, ED is 2 times FE. So ED is also 2 times FE. So, I mean, like, if we had labeled this FEX, this would also be 2 times FE. And then it says here, prove that BCDE is a parallelogram. Well, proving that this shape is a parallelogram, you need to show that opposite sides are equal and opposite sides are parallel. So fortunately, here we need to tell them we know that BC is also 2 times FE. So let's tell them. BC is 2 times FE. The reason is midpoint theorem. Midpoint theorem. And then you're then gonna say therefore BC is equal to ED, you see, because you have proven it there. It's more of a conclusion now. But then now you need to show that those sides are also parallel to each other. So you need to tell them that you know that FE is parallel to BC. The reason is midpoint theorem also. Theorem. So here, because FE is parallel to BC, you can also then state that ED is parallel to BC. The reason is FED is a straight line, you see, because if the whole thing is a straight line, it means that if a portion is parallel to BC, it means the other portion is also parallel to BC. So since you've proven that the opposite sides are parallel and you've proven that the opposite sides are also equal, it means that you can now state that therefore your shape BCDE is a parallelogram. You see, it's a parallelogram because opposite sides because a pair of opposite sides because a pair of opposite sides are equal, right? Because you saw a pair of parallel sides that are equal and parallel. A pair of sides that are equal and parallel. You have shown that in your calculations. So that's good enough. Let's move on to the next question. Question number 8. It says, a sealed sphere filled to capacity with a colorful liquid has a diameter of 5 centimeters and fits tightly inside a cylinder. The sphere bursts and is removed. The liquid spills into the cylinder. At what height is the cylinder filled? Okay, so these kinds of questions don't overthink it. The idea is the top of the sphere is touching the top of the cylinder, the bottom of the sphere is touching the bottom of the cylinder, and the edge of the sphere is also touching the edge of the cylinder. Now they're saying here there's a sphere, right? Inside it there's some water. They put this sphere inside this cylinder. Now this cylinder has a certain capacity, the sphere has a certain capacity. So the sphere like pops, right? It bursts, and then all that liquid goes into the cylinder. And then now they're asking which height the liquid spills into the cylinder. At what height is the cylinder filled? So in this situation, you wanna think logically, you see, because if the cylinder spills, right, you have to remember that a lot of the liquid that was on top here would go and cover this space down here. And then once that space down there is covered, half of the sphere will also at least be covered, and then a bit more. So this is quite an interesting question, but without overthinking it, let's just compare the different volumes of the sphere and the cylinder, because all you want to do is you want to take the volume of the sphere, compare it to the volume of the cylinder. That's all you have to do actually. So let's take the volume of the sphere, right? The volume of the sphere, they gave it to us here. It's like volume of our sphere. You don't have to rewrite the formula. You can just use it, you see. 4/3, radius is 5. So what do you have now? You see, 5 cubed. So it's like 4/3, right? And then you have like shift pi. And then you have like 5 cubed here. That's like 500/3 pi. That's the volume of the of the sphere. Now the cylinder, let's see, volume of cylinder of cylinder. Let's see, the volume of the cylinder is going to be pi radius squared. The height of the cylinder now, the height of the cylinder is going to be double the radius, because you see radius going up and then radius again, you see, because remember the sphere touches the bottom of the cylinder all the way to the top, so that's like 10. That's the height. And then the volume of the cylinder here, pi r squared times the height, that's like 500 pi. I mean 250 pi. Why did I get 500 from now? 250 pi. So now what you know is, you obviously know that the volume of the sphere is lower than the volume of the cylinder. So when all the volume of the cylinder, when all the volume of the sphere goes into the cylinder, you wanna keep in mind that your sphere, only 500 over 3 pi goes into the cylinder. So let's just see what this is as a decimal, so that you can almost get an idea of, visually how this is going to look. So let's see, shift pi here. So this number is around 523.6. This number here, 250 pi, is around 785.4. Now the big idea is your cylinder, right? You have to look at it like this. This is like your cylinder if you're looking at it from the front. Now what you know is the volume, the full volume here, the full height here is 10, right? But then the full height here is 10. Let's say here height equals to 10, right? But then the volume of the full thing is equal to 785.4. However, when the liquid from the sphere pours out, right, it's only going to cover what you may call 523.6 centimeters cubed. So meaning the liquid is going to go all the way until there. So this volume here that's in green, right? This volume that's in green is 523.6. So we want to work out which height it would end up at. You see. Now to get that height, you can just use again a volume of a cylinder formula, because you can now say the volume of the green here, right? You know it's equal to 523.6. That's the volume, right, of a cylinder that would end there. So that volume, you know, it is equal to pi r squared. Pi, the radius is still 5, but then the height now is a value you don't know. So we can even label this x. And then here you just have to solve for x. This is going to be 25 pi x. Okay, so here we can just divide by 25 pi on both sides, right? So divide this by 25 pi. Divide that by 25 pi also. So your x value is going to be equal to 523.6 divided by 25 pi. That's going to give us 6.7. There we go. Therefore, height is equal to 6.7. But then, is that all that they want? 6.7, 6.7. Let me just look at this for a bit longer, because I was using the wrong dimensions. They say the diameter is 5, not the radius. This sucks. This sucks so bad. Yeah, so I just have to change this to half which is 2.5. I have to change this to half, which is 2.5. And then let's change this value here and this value here. So let's see what that's going to be. This is going to give us 65.4. And then this one is going to give us, what is my height for the cylinder here? Shift pi 2.5 squared times the 10, no, times the 5 in this case. Because if the diameter is 5, it means that the height is also automatically a 5. So let's see, this one is going to be 100. It's going to be 98.17. So just for visual, for the visual aspect, this whole thing here would be 98.17. The height would have been a 5. So here we know that the volume here is just the 65.4. And then here you can see that you would have here 2.5 over there, 2.5 squared. And then let's see what that would have been. Shift pi 2.5 squared multiplied by, let's see, this would have been like 25 over 4 pi, of which you would have divided that on both sides. So you'd have divided by 25 over 4 pi. This cancels this, and then 25 over 4 pi. You see. Now, what does this give us now? All this considered, well, funny enough, because we had used like double the radius, everything literally just doubled. But the moment we use like half the radius, everything also just, logically speaking, it just halves. So here's 65.4 divided by 25 over 4 pi. Let's see what that gives us. It's going to give us 3.3. X is equal to 3.3. And then you can say therefore height is equal to 3.3. Okay, let's move on to the next question. Question number 9, right? For 5 marks, it says if sine A is equal to this expression and A plus B is a 90-degree angle, use a sketch to find tan B. Well, you don't, normally when you see stuff like this, the sketch that they would want you to draw is a right angled triangle, any random right angled triangle. So here the angle is A. This is going to be 90. Automatically, this is B, because if you have a triangle and you're dealing with sine, for trigonometry to work, right, like sine, cos, and tan, opposite over hypotenuse and all that, it has to be a right angled triangle. Your opposite is like 2x. Your hypotenuse is 1 plus x squared. Your adjacent, you can always just work it out using Pythagoras. So let's just get some space here. So using Pythagoras, let's see what we can do here. The hypotenuse is the line AB, right? So 1, so this here squared is equal to 2x squared plus, let's just label this. What can we label this? Let's use a random variable. Let's use m. So here 2x squared is like 4x squared. Want to isolate m, remember. So here, this, let's just leave it the way it is. But let's just see. 1 times 1 is 1. Let's just expand it. 1 times 1 is 1. 1 times this is like x squared. And then another x squared. And then x to the power 4. Okay. since you're gonna isolate m, right? Let's see everything on one side except for the m squared. You're gonna have x power 4. 2 minus 4 is gonna be a -2. And then the 1 there. Square root both sides. You have square root x to the power 4, 2x squared plus 1. And then this is m. So obviously, the one thing you wanna take into consideration here is what else? What do you wanna take into consideration here? Yeah, you wanna take into consideration quite a lot of information. So that's just m. You have m now. So it's okay. You can now use it for whatever it is that they are talking about. But then what you want to keep in mind here is, fortunately, you have to keep your eyes peeled. You see, if you look nicely here, we have the difference of two squares, because before you even carry on, right, you have to remember that here the difference of two squares means you have ax. No, we don't have the difference of two squares. No, we have a quadratic equation, because we have something that can be squared and then something not squared. Let me just put it this way. Our equation is in this format. A something squared plus B something not squared plus C. You see, this can be any variable. K or X, doesn't matter. Anytime you have a situation like this, you can always factorize. So in our case, here we can write this as x squared to the power of 2. And then x squared here, right? Plus 1. Now, what you're seeing here is that you can factorize by saying factors of 1 that give a -2. It is just going to be 1 and 1. But then for -2, it has to be -1 and -1. Then there's x squared here, x squared there. So this is like x squared and x squared. You see, and then you have x squared -1 twice under square root. So you can see here that the square root cancels the square there. Your value of m is just x squared -1. There we go. So this is just the difference of two squares, but it doesn't matter. Now, with what we have here, they want us to get tan b. So tan b is obviously going to be opposite over adjacent, you see. There you go. You can leave it like this. It is 100% A-okay. You will not be penalized for that because it is 100% up to you. B says 6 equilateral triangles. Equilateral means all the sides are equal and all the angles. So 1, 2, 3 are equal. All these are equal. And then it says here, 6 equilateral triangles are stacked next to each other to form a parallelogram. And then it says here the area of the parallelogram is this much. So it's like 1, 2, 3, 4, 5, 6. Well, obviously the area of one triangle is this divided by 6. Determine the length of one side of the triangle, of each triangle. That's easy, because firstly, you have to remember that with a parallelogram, the area of a parallelogram, we have it. So the area of one triangle, area of triangle is equal to this value here divided by 6. So that's giving us the area of one triangle, which we do need, because if we at least have the area of one triangle, that's one step closer to working out that length that they are talking about. You see, so let's even leave it like this so that it's not rounded off. So the area of a triangle, remember, it's just half base times height. You see, half base times height. So this value is equal to half base times height. So without overthinking this question, right? We want to keep in mind that we wrote down the area of a parallelogram over there. And the one other thing that we want to keep in mind is, remember we said that all the angles and all the sides of your equilateral triangle are equal to each other. So automatically you know that this is 60 degrees, this is 60 degrees, and up there is 60 degrees. It looks as though incorporating the x's is going to be helpful, because at least here you now know that going downwards, this is just going to be half of x. You see, and we can easily solve for x because you can say adjacent over hypotenuse. That's cos. So you can say here cos 60 is equal to adjacent over hypotenuse. And then you can see here the x's cancel each other out. Oh, bugger, bombs out. Well, this is a true statement, but it doesn't help us get anywhere. So obviously we might as well maybe then get the hypotenuse. I don't even know why I was writing this out. The height, sorry. Here to get the height, you can say opposite over half x, or you can even just say you can even use opposite over hypotenuse. You can also use sine. It doesn't matter what you choose to use. So sine 60 is opposite over hypotenuse, which is x. But then we don't have x and we don't have h. So fortunately, what we can do is you can get an equation that has x and h. And then here you can have one variable. And then you can solve for whatever one variable you solve for. Because if you get any of these one variables, you're good to go. But obviously we want h. H is easier. So let's just get an equation that has x and h. The one equation that will have x and h is Pythagoras. So we can say here x squared is equal to h squared plus a half x squared. So this is like h squared plus a quarter x squared. And then everything on one side except for the h squared, you're going to have 1 minus a quarter. That's like 3/4. And then you have here square root of each side. Square root, that's like h. And then you're going to have square root. In the calculator, this is what it's going to come out as. You see. So since you want a value of h, right, wherever you can think to yourself, wherever h is, you can now get a value of x. And then obviously the moment you let's see, determine the length of one side of the triangle. Remember, the moment you get h, which is this value here, we can throw that into this equation, right, and then solve for x, because x is going to give us the length of one side of our triangle. So let's see here. Let's write this in blue. So in blue here, we can put the sine 60. H is like square root of 3 over 2x, the whole thing over x. So the x's can just, well, the x's will just cancel out, and then that just comes out. Ah, come on, bro, come on. So you cannot use this equation here to get h, because it gives a true statement, but it doesn't help us. So I guess this is where the areas of your triangles come in, because now you can say the area of one triangle, right? Remember, the area of a triangle area is going to be half base times height. Let's see. Area, maybe half the base times the height. So your base, you know, it's just x. The height is just square root of 3 over 2x. And then we said that this is going to be 147 point, no, 147 square root of 6, square root of 3 with a 6 there. And then you have here, these two are being multiplied together. So you're going to have like square root of 3 over 4. And then x squared. 147 square root of 3 over 6. And then you can divide both sides by the square root of 3 over 4. Square root of 3 over 4. So this cancels this. So x squared is equal to this whole thing here. So x squared being equal to that whole thing. Let's see here, 147 square root of 3 over 6, right? Divided by square root of 3 over 4. That's like 98 on the dot. Wow. Square root both sides. You then have there 9.9 is the final answer. X is equal to 9.9 if you round it up to one decimal place. Wow, I guess as a last question, this question was quite extra because it's like, whoa, bro, come on. It's only, I think, 4 marks because I think based on the total, since we're at the end of this paper, I mean, like, you've really got an idea of how, so since this is a paper out of like 110 marks, it looks as though this question, they only had to make it 4 marks so that they could reach 110. But from the looks of things, it's clearly a question that is going to be worth more than 4. But this is this paper, everything worked out, everything all good. Now remember, the tutorials on like different sections of the work, right? You can get that from the main channel. So if you go on the main channel, you will see there that you are going to be able to like work on the different topics that you need to work on, the different tutorials in the different playlists. So that is that from my side. Obviously, depending on how much you need to improve on your maths, or depending on how much you're willing to put into your maths, you can always hop onto the online courses platform, and then you can always sign up for the online courses. I mean, like, depending on when you're watching this, you may bump into a sale, something like that. But anyways, from my side, I will catch you in the next video.